For 19 million years, something invisible showered our planet with rock falling from directly above the equator. Every single impact crater from that era clustered within 30 degrees of the equator, and nobody could explain why. Then in 2024, scientists proposed an answer that sounds impossible. Earth once wore a ring, just like Saturn. Now, imagine that ring never disappeared, and Saturn's rings crashed into our planet instead, starting today. Saturn's rings stretch 282,000 kilometers wide, yet stand barely 10 meters thick, thinner than a football field. Billions of ice fragments drift inside them, ranging from grains of dust to chunks the size of a house. NASA's Cassini spacecraft confirmed these particles are almost pure water ice, dusted with rock and dark organic material. If that entire structure suddenly wrapped around Earth, every satellite in low orbit would face immediate annihilation. But the real danger isn't the collision. It's what happens in the years the debris keeps falling. To understand the coming catastrophe, we have to go back 466 million years to Earth's forgotten ring. Geologists call it the Ordovician meteor event, and it left fingerprints scattered across 3 separate continents. For centuries, scientists assumed the craters were random, until someone finally mapped exactly where each one landed. Every crater from that period sat within 30 degrees of the equator, an impossible pattern for random impacts. Random asteroid strikes hit anywhere on Earth, from the poles to the tropics, with no favorite latitude. Yet here, more than 70% of Earth's landmass sat outside the impact zone and stayed untouched. Geologist Andy Tompkins and his team at Monash University proposed a radical explanation for the strange clustering. A massive asteroid had wandered too close to Earth, crossing an invisible boundary called the Roche limit. Named after mathematician Edouard Roche, this limit marks the point where a planet's gravity overpowers an object's own. Cross that line, and gravity doesn't just pull you in, it tears you apart, piece by piece. Scientists compare it to spaghettification near a black hole, only gentler, stretching rock instead of shredding atoms.
The doomed asteroid shattered into a spinning trail of debris, caught in orbit instead of falling straight down. That debris spread out into a thin, glittering band, circling Earth's equator, exactly like Saturn's rings today. For millions of years, chunks of that ring rained down slowly, striking the same narrow equatorial strip repeatedly. Chemical analysis of ancient meteorites revealed a rare fingerprint, L-chondrite material, matching the shattered asteroid perfectly.
These fragments showed less exposure to cosmic radiation than typical meteorites, meaning they fell fast, not slowly. That detail confirmed the fragments came from something orbiting close by, not drifting for eons through deep space. Then something else happened. A global cooling event scientists call the Hernantian Age, arriving right on schedule. Temperatures plunged, ice sheets expanded, and one of the coldest periods in Earth's ancient history began. Could a ring of debris have dimmed the sun enough to trigger an ice age purely by blocking light? If it happened once by accident, what would happen if we recreated that event on purpose, right now? Picture the moment. A fragment of comet or asteroid drifts inside Earth's Roche limit, roughly 17,880 kilometers out. Tidal forces stretch the object first, then snap it apart in a silent, slow-motion explosion of rock and ice. Within days, thousands of fragments spread into a thin band circling the planet along the equatorial plane. Unlike Saturn, Earth sits far closer to the Sun, and that single fact changes everything about survival. Solar heat immediately begins vaporizing any ice within the debris, turning solid fragments into streaming gas trails. Ultraviolet radiation strips remaining water molecules apart, meaning an icy ring here could never last long. A rocky, silicate-based ring, however, would resist the sun's assault and could persist for centuries undisturbed. That ring would settle somewhere between 1,000 and 17,800 kilometers above Earth, a razor-thin equatorial highway of debris. Every satellite orbiting inside that zone, roughly 80% of everything humans have ever launched, faces destruction. GPS satellites orbit near 20,000 kilometers, just outside the danger zone, offering one small mercy amid the chaos. Communication networks collapse first, as low Earth orbit constellations shred against gravel-sized fragments moving at orbital velocity. A single ring particle the size of a coin carries enough kinetic energy to destroy a satellite instantly. Weather forecasting fails, GPS navigation becomes unreliable, and half the modern world's infrastructure quietly goes dark. Meanwhile, gravity constantly tugs loose material from the ring's inner edge, sending it spiraling toward the atmosphere. That falling debris ignites on entry, turning Earth's night sky into a permanent, relentless meteor shower. Unlike a normal meteor shower lasting one night, this bombardment would continue for years, maybe centuries. Fragments large enough to survive re-entry would strike concentrated along the equator, echoing the Ordovician pattern exactly. Nations near the equator, Indonesia, Brazil, Kenya, would face the highest risk of catastrophic ground impacts. Meanwhile, the ring itself would cast a faint shadow, dimming sunlight across equatorial regions during specific seasons. That shadow wouldn't just look beautiful, it would quietly begin cooling the planet from below. Here's the revelation nobody expects. The ring wouldn't need to block much light to change everything. Climate models suggest even a small drop in solar input can trigger feedback loops that spiral out of control. More ice reflects more sunlight back into space, which cools the planet further, which creates even more ice. Scientists believe this exact feedback loop may explain the Hernantian ice age that followed Earth's ancient ring. In other words, the ring didn't just rain rocks down on Earth. It may have reshaped the entire climate. A modern ring event could theoretically trigger a new ice age within decades, not centuries, according to current climate modeling. Global temperatures could fall enough to disrupt agriculture across entire continents, threatening food security for billions of people. The most unsettling part, we would likely see this asteroid coming years before it ever reached the Roche limit. Space agencies already track near-Earth objects capable of triggering exactly this kind of catastrophic breakup event. NASA's Planetary Defense Coordination Office exists specifically to identify and monitor these civilization-altering threats before they arrive. The good news? An object large enough to form a lasting ring is exceptionally rare in near-Earth space. The unsettling news? Rare doesn't mean impossible, and Earth has clearly crossed this threshold at least once before. Some researchers even wonder whether Earth's ring debris altered evolution itself, favoring species that survived the darkened skies. The Ordovician period ended with one of the largest mass extinctions in Earth's entire fossil record. Scientists still debate how much of that extinction connects directly to the ring, and how much to other causes. What remains certain is this. Rings are not just decoration for distant gas giants. They are dangerous machinery. Saturn's rings look peaceful from 100 million miles away, a delicate halo circling a golden giant. Up close, or wrapped around a living planet, that same structure becomes a slow, patient weapon of erosion. Earth already survived one ring. long before anything with eyes existed to look up and wonder. The next time you see Saturn through a telescope, remember, you may be looking at Earth's forgotten past and possibly its future.